Types of threads. Square threads. The square thread form is a common screw thread profile used in high-load applications such as lead screws and jet screws. It gets its name from the square cross-section of the thread. It is the lowest friction and the most efficient thread form, but is difficult to fabricate. Trapezoidal threads. Trapezoidal thread forms are screw thread profiles with trapezoidal outlines. They are the most common form used for lead screws, power screws. They offer high strength and ease of manufacture. They are typically found where large loads are required, as in a vise or the lead screw of a lathe. ACME threads. The original trapezoidal thread form and still probably the one most commonly encountered worldwide, with a 29-degree thread angle, is the ACME thread form. This profile is well suited to power screws and have various advantages over the square threads. Advantage of a square thread over the trapezoidal threads: higher efficiency, no radial pressure or side thrust on the nut. This helps to keep the motion of the nut uniform and increases the life of the nut. Disadvantage of square threads. Square threads are difficult to manufacture. The strength of the screw depends on the thickness at the core diameter. Square threads have a lower thickness as compared to trapezoidal threads at the core. Wear of the thread surface is a serious problem in the service life of the screw. It is not possible to compensate for this wear in square threads. Advantage of trapezoidal threads over square threads. Trapezoidal threads are economical to manufacture. Trapezoidal threads have a large load carrying capacity. The axial wear on the surface of trapezoidal threads can be compensated by using split-type nuts. Disadvantage of trapezoidal threads: lower efficiency as compared to square threads. Trapezoidal threads result in side thrust or radial pressure in the nuts. Buttress threads. Buttress thread forms, also known as sawtooth thread forms, are screw thread profile with an asymmetric shape, having one square face and the other slanted. They are most commonly used for lead screws where the load is principally applied in one direction. Advantages of buttress threads: higher efficiency, economically manufactured on thread milling machine. The axial wear on the surface of threads can be compensated by using split-type nuts. A screw with buttress thread is stronger. Disadvantage of buttress threads: it can transmit power and motion in one direction only. Applications of various threads: square threads, screw jacks, presses, clamping devices, etc. Trapezoidal threads in ACME threads, lead screws and other power transmission devices, machine tools. Buttress threads, vices ideally suited for connecting tubular components that carry large forces, such as connecting barrels to a housing in an aircraft gun. Isometric types. Isometric threads. The isometric thread is a worldwide standardized thread and is probably the best known and the most used in Europe. It is also known as a standard thread. Pitch and diameter are measured in millimeters. The code letter for the metric thread is capital M. The flank angle is 60 degrees. Furthermore, the type of thread is precisely defined in DIN standard, DIN 13 and DIN 14. DIN is a German Institute of Standardization. Isometric fine thread, that is MF. The isometric fine thread is similar to the bigger brother of the isometric thread. Here the code letters are MF and the flank angle is 60 degrees. However, both differ in the pitch. The metric pitch thread is used in watches. American thread. For the American thread types, the dimensions are always given in inches and 1 inch is equal to 25.4 mm. The flank angle is always 60 degrees. The main difference between the various American unified threads is the pitch of the threads. These are also indicated in the threads per inch. To determine the pitch, the number of threads is counted in 1 inch, that's TPI. American thread types. Unified National Coarse Thread UNC. The unified screw thread is a standard thread which is mainly used in USA and the American equivalent of the metric ISO thread. Only the unit of measurement, inch instead of centimeters, is used. The flank angle is as with the ISO thread 60 degrees. Unified National Fine Thread, that is UNF. The same applies to the Unified National Fine Thread type, which is the American fine thread, to the isometric fine thread. As with the UNC, the flank angle is 60 degrees. Unified National Special Thread, that is UNS. The thread type UNS is a special thread which differs from the other unified thread in the pitch. Here too, the flank angle is 60 degrees. This thread type is used for microphone stands, among other things. British Whitworth threads. The Whitworth thread is named after its inventor Sir Joseph Whitworth. The British engineer introduced the world's first thread standardization in 1841 and thus influenced the mass production of threads. The Whitworth thread is specified in inches and has a flank angle of 55 degrees. This type of thread is mainly used in British Kingdom. British Whitworth thread types. British Standard Whitworth Coarse, that is BSW. The British Standard Whitworth is on one hand a standard thread and on the other end is a screw thread. It is often abbreviated with the abbreviation W or WW. In terms of meaning and use, it is equivalent to the isometric thread. It is specified in inches and has a flank angle of 55 degrees. British Standard Fine (BSF). The British Standard Fine is the English variant of the fine thread. The meaning and the use corresponds to that of metric thread fine threads. The thread is also specified in inches for the BSF and has a 55 degree flank angle. British Standard Pipe, that is BSP. The British Standard Pipe is a Whitworth pipe thread. It is a cylindrical thread and therefore not self-sealing. It is abbreviated with the abbreviation G, capital G. A small special feature is that the inch specification does not correspond to the inch diameter. For example, BSP 1 inch is equal to approximately 33.25 mm. What are multiple thread screws and multi-start screws? Multiple threaded screws are used where higher traveling speeds are required. These screws have two or more threads cut side by side around the rod. In multiple threaded screws, the lead may be increased by increasing the number of starts without increasing the pitch of the screw. Advantage of multi-start screws. It provides large axial motion per revolution of the screw. The efficiency of a multi-start screw is higher than the single-start screw. Disadvantage of the multi-start screw. The mechanical advantage obtained is lower as compared to single-start screws. The self-locking property may be lost in multi-threaded screws. Thank you.